what I have in front of you guys, this is an unassembled DC load. So I'm just gonna attempt to make a more advanced DC load. I think you guys can see all this clutter on my desk. So this DC load will be better than, I don't know if you guys still remember this one, the OG DC load that I made on one of the videos. If you haven't seen that, I'll just link it on the top right hand corner of the screen. So this DC load in short was just a bunch of 10 ohm resistors that are controlled by this switch. If you plug in like a 5-volt load, let's say you want to measure one of our power supplies, if you put in like 5 volt on there, then you can go in ranges of 0.5 amps. So every time you switch on this switch, it goes on for like 0.5 amps. So today I'm just gonna build this guy. I'm sure some of you can already recognize the stuff which is on there. I'm just gonna put chapters on this video because I believe this video is gonna be long. So if you wanna skip to your favorite part, just use the chapters on there. But I can quickly go through the components that I bought. These are the components that I bought. We have a couple of resistors here. This is like 10k resistors. This is like 1k resistor. This is a 5-volt fan. So what I'm gonna use this fan for? It's for, I wanted a bigger heatsink, but they didn't have a bigger heatsink, so sadly I have to go with this guy. So if things get a bit toasty, we have our 5-volt fan here. And we have our op amp. This is like our op amp. That's what we're gonna use. We have a 0.1 ohm resistor, 10 watt. This is basically for current sensing. Nothing major on that. This is like a volt ammeter. I don't know if you guys can see it properly. This is what it is. A couple of caps. This big MOSFET is what we're gonna use for damping power to ground. Some knobs. I don't know if I can put it here. So basically this is just a regulator for this fan. Some caps here. I'm not actually going to use all of these 4 regulators, maybe 1 or 2 on the, and this is just thermal paste just in case we're gonna have to, if this thing gets a bit toasty. And on the bottom side of things, this is the PCB. So this PCB substrate, this is what I'm gonna try to do. I'm just gonna, I didn't want to put too many cables on this, like do like a cabling mess, so I was trying to put everything on here. So hopefully it works. So it's gonna be like on one side only. For example, this thing will be like on the front here or something like that, but we'll see as the video goes on. So I'm gonna be assembling this thing in like parts, so I can't assemble everything because there's a lot of things happening here. So I'm gonna try to assemble it as in stages. So there's gonna be like a power regulation stages where I'm gonna put the regulator, the fan, the potentiometer, and some caps. Then eventually I'm gonna do another stage where I focus on this side of things, then the cooling and all those stuff. But I'm trying to make it in stages, so just bear with me because now I just need to find a layout where I can put this on. So remember, this is DIY. You can actually make this stuff by yourself at home. You don't have to have like precision machines to do this. So I'm just gonna try to do some markings, make my way on how I'm gonna position everything. So yeah, just stick around and hopefully it works out. So far this is what I have. So I just tried to make a track right here. I just used one of my razor thingies here. So I'm just trying to connect the op amp to the potentiometer with there's a cap there for smoothing purposes. The reason why I'm doing all of this is because I wanna incorporate, I don't know if you guys still remember this. Let me show you guys. I don't know if you guys remember this USB detector. So I'm trying to incorporate basically these two things together, so that when I plug in the USB, we can see the current. We can also using this rotary dial, we can actually change the current drawn. So this is where I am right now. So I'm just gonna try to finish up. I mean, it's a bit of a mess here, but I'm just gonna try to finish up and connect the other sides, and hopefully I'll be back with you guys. So this is what I have so far. I don't know if you guys like it if I put it on the screen when I'm doing soldering and stuff like that, or you guys prefer me jumping to already built up stuff. If you prefer me putting the editing where I have to solder and every stuff, just write it in the comment down below and let me know how it is. But so far this is what we have. I just managed to put this heatsink. It's not much, but I don't want it to charge the ground. That's why I use some some hot glue on it. And this is the MOSFET. It's kinda there. This is the 0.1 current sensing resistor. So I'm just gonna quickly do that. Our op-amp, we're busy connecting our op-amp there. So obviously we still have our fan in the display right here, so just gonna sort out that in a few minutes. And also we still have some caps left over, so I'm just gonna sort that out. But yeah, so far it looks like it's going all right. I'll catch you in the next one. Hopefully by then we should have some progress. So this is what I have so far. I'm just gonna mount the fan somewhere around here, and hopefully it blows air. Hopefully it will cool down, because I placed some thermal paste between the heatsink and this MOSFET. So now I'm just gonna put this. I mean, I already have this screen right here. It's not falling out anytime soon. So this is my messy soldering right there. And yeah, let me just put this fan on here and connect, because right now eventually I have to get like create like some sort of trace for the input V in from our external power supplies or whatever. But yeah, so this side, it's this power supply. I'm just gonna use a 12-volt power supply, because this is a regulator. So it's gonna have an external power supply to power the fans and all those stuff, because I don't want to draw current from what we are testing. I actually wanted to see the real current displayed on here. So let me do that, then hopefully I'll be with you guys in a minute. So this is what I managed to get so far. So I just created a temporary, not a temporary, but I just created makeshift track right there. So this is your positive, then this is ground. Basically ground is everywhere. So this part, you can imagine that it doesn't exist. I think I can even write it down. I think anything after this line, just imagine that it doesn't exist. So right now I'm just gonna take from the old DC load, because I really need this USB connector right here. So I'm gonna take this and put it here. Then hopefully we should be done, and I'll just have to put a 12-volt power supply, like basically another charger to power the fan and the other stuff. But yeah, that should be it. I'm just gonna put this guy here, and hopefully we should be done and we'll be ready to test. I'm just gonna use my multimeter real quick and see if there are no shorts. I can't find that fancy multimeter that I made with the USB Type-C. Again, link at the corner right there. But I can't find it, so I just grabbed what I have. I just wanna see if, yeah, it does work. I just wanna see if there's shorts. is a short on this line. Possibly there's a short on this line. I'm just gonna investigate where it's coming from, but yeah, then I'll be with you guys. All right, so quick update. One thing happened. So this big MOSFET here blew out, not necessarily like as in over voltage blew out, but ESD wise. So what happened is the way I handled it, it blew out. I don't know, it's something inside happened, because every time I'm measuring the continuity on the positive side, it was beeping, or it was the resistance was very low. So in that case, I kept on tracking it. I even removed a lot of stuff, and it kept on bringing me to this MOSFET. So apparently the source and the drain were directly connected, as in let's see, this is the gate. So this guy and this guy, I mean, already this guy already goes to ground because of this 0.1 ohm resistor. So it kept on beeping. So yeah, I had to go out and buy a new one, and this time I made sure that I'm wearing ESD shoes. Yeah, ESD rated shoes, so hopefully that works. But yeah, I ended up buying this new MOSFET, and since I blew that one out of ESD, I didn't know if our regulator over here survived. So this thing has been running for a few days now. So to get this video out, I'm just gonna make it work on this little setup of mine. Cutting this, I'll do it in another video. Putting it in everything in a case, I'll do it in another video. So I'm just gonna try to make it work. So even my fan went out, but yeah, I'm just gonna replace this thing carefully this time, hopefully. Then if this thing goes well, then I can tune it with our potentiometer, and hopefully we'll get some results, because after all, this thing was almost done. So this is the USB port. It's not the best in the world, but should do the job. And also this is our charger. Remember this charger? Yeah, video at the corner of the screen. But yeah, I'm just gonna use this charger because I wanted the 9 volt. I didn't have a 9 volt power supply nearby without destroying something else. But yeah, I'm just gonna quickly do that. Remove this, mount this guy, and hopefully it works. Or maybe I should test it before mounting. But yeah, hopefully I'll be with you guys. All right, I managed to solder that one out, and I was just quickly testing this MOSFET to see how it is. Looks like it's working good. I managed to take some precautions this time around, using my tweezer. I don't know if it's ESD, but yeah. So I managed to do that. Hot glued the fan into place. The screen is there. Hopefully it does. Added some capacitors here and there. Looks all right. So now I'm just gonna do the moment of truth. Plug this guy in. Take some few measurements, because I'm expecting it 5 volts, and the moment I plug it in, the fan should kick on. I don't know, can I put it like this so that you guys can see? But let me just put the potentiometer to its lowest settings. Yeah, so let me just plug this guy in, and hopefully no kabooms. Here we go. On 3, 2, 1. I hear the fan. I hear something. It's on. I don't know, can I pick it up? I don't know if you guys can hear it. The fan is on. The screen in front, if I can tilt it like this, the screen in front is on. So looks like we're in business. Let's see what we can do. But yeah, looks like we're in business. Let me show you guys the fan. Damn, it's actually powerful. Look, receipt of some sort. But yeah, looks like it's going all right. I don't know if it's pulling. Let me just do some measurements before I get too excited. Okay, so I've been going up and down with this guy, and looks like I was connecting a few things wrong. Obviously I had to investigate this. So this MOSFET wasn't turning on. I thought I blew it again, so I did some diagnostic and managed to get it to work and turn on the system. Also, this thing came out, so right now I'm measuring a 9-volt battery at the moment, but I couldn't increase. Every time I tried to increase the current drawn, this is what happens. It goes down. So obviously this battery is not really that powerful. So what I'm gonna try to do is put in a power supply, like a charger. Try to crank it up and see if it works. But yeah, I did have to do some modifications. I don't know if you guys can see here. I had to add these resistors because the voltage on this guy was too much. So basically we need a range of 0 volts to 0.5, I believe. 0.5 gives us like 5 amps, so I try to minimize it. So if you pump in 5 volts on here, the difference between 0 volts and 0.5 is like a hair. So if you do this like tiny, it would have spiked. So what I had to do is like reduce the voltages so that the resolution is better. So I'm just gonna disconnect this. Also, I can't connect this on this ground plane. I have to connect it directly to this. So I'm just gonna change this setup and see where it takes us. But otherwise, this thing has been a pain in the ass to do. Otherwise, this thing was a pain in the ass to do. But let me see what I can do. Hopefully this time works. All right, apologies, my desk is a mess. I've been working on this thing for days now. There's something that I'm struggling with. You see this voltage ammeter. Every time I try to measure the voltage coming from this charger, somehow it doesn't want to read it, but every time I put it to read the voltage, which is regulated, this 5 volt right here, it actually reads it perfectly. So I've been trying. I mean, even the current keeps on oscillating up and down, like it's running like haywire. I tried to put capacitors to dampen. You can see these blue capacitors. I tried to dampen the power, so nothing works. I even tried to place a capacitor like on the input where the charger is coming in. Still, I couldn't find where the fault is. I mean, if I try to measure a 9-volt battery, it does measure, but my 9-volt battery, it barely can't even you can't even draw an amp on those. No, you can't. But if it's a regulated, as in it's a stable 9-volt battery, somehow it reads it nicely. But because of this, it wasn't reading it nicely, and I'm not. The fan works, everything else works. The knob does work to some degree, but I can't really test it because this thing doesn't read anything. So this project will be postponed, not because it didn't work, but I still need to research a few stuff, and I need to publish the video so that you guys can have something to watch on. But yeah, because if this thing worked, the next video was gonna be me putting it in a case and actually trying to use it out, because this is like the blueprint of what I have. And so I added some resistor here to reduce the voltage of the potentiometer. Yeah, so yeah, that's pretty much it. But this project is not cancelled. I'm just gonna pause it because I've been working on this for days now. I even blew like a lot of MOSFETs. I think. Now these are the regulators. I don't know what happened to that MOSFET. It blew out of ESDs, and something shorted yesterday. So yeah, anyways, I'm gonna continue researching on how this thing actually works. I'm sure there's some signal oscillating in the I don't have an oscilloscope to actually tap into this system, but I know this PCB, this material is an FR4, which is not the best in the world. I'm sure Rogers does a much better job, but I'll see. Hopefully when I get it to work, I'll have to come back to you guys and not teach you, but show you what went wrong, which part I did wrong on my part. And if anybody in the comments below knows what actually might be the issue, just let me know down in the comments below, and I'll be reading your comments. So this is pretty much it. Everything else works except for this guy, so I cannot see how much current I'm drawing. And if I put a multimeter here, it does work. The multimeter reads 5 volts, but remember, multimeters they actually do an averaging. So hopefully it will work out, because multimeter can see but this thing doesn't. I'll just have to research more, but yeah, hopefully you like videos like this. If you do, you can give me a thumbs up. If you are also there, you might as well just subscribe, but that's all up to you. I'll leave that in your hands. But guys, I think I'll see you guys in the next video. Cheers.